Hi, it's Michael McKinnon from Sense of Security. In this video, we're going to demonstrate an attack on a typical AWS cloud-based environment that's similar to many real-world infrastructure environments. Welcome to our DevSecOps lab. We've created a working development environment for our security automation in DevOps tutorials and workshops, so we can research and study some of the risks that are inherent in some of the common DevOps tools and platforms and in cloud environments. This network diagram shows us the layout. Let's familiarize ourselves with it because what you're about to see is a recorded attack that begins with a simple internet scan and ends up with a total AWS account takeover. Starting over to the left, we have an isolated VPC or virtual private cloud. Imagine, if you will, that this is our cloud-based development environment. Over here we see a Jenkins server. This is a popular continuous integration platform that many DevOps environments use. This left-hand side of the network we consider to be internal, and as such, we don't want any unauthorized access to this segment of the network. Now, as we look to the right-hand side of our network diagram, this is the public part of our network, where our public-facing servers would reside, either directly accessible or through a load balancer, as is common in AWS environments. While we still take precautions to harden the servers running in this side of the network, it's not as protected as our internal side. Meanwhile, connecting these two separate networks together is a VPC peering arrangement, and this is a link between the two VPCs. Let's get started now with the attack scenario and see what happens. The first thing our attacker does is starts with an Nmap scan. And in this scenario, we're assuming that the attacker has already scanned the internet across public IP space and found this particular IP address for our target, which is publicly accessible. The Nmap tool is capable of discovering ports, such as in this case port 8080 and port 22, you can see on the bottom of the screen. And this is a standard network testing tool, enumeration tool, and Nmap is actually capable of doing a lot of things as well. We'll wait now for the output from this command to complete, and you can see here that the scan took about 30 seconds and we found the SSH port 22, and we've also found something interesting here, port 8080, which is coming back and saying that it's an Apache Tomcat, which is a web application server, a Java-based platform. Our attacker then decides to take this IP address of interest, open up a web browser, and look at what is this thing on port 8080 on this particular IP address. And in this case, we can see it comes back with this some sort of web page saying production application alpha. But we probably want to get a bit more information about what's running on this particular web port. And in this case, we can run a tool called Skipfish. Skipfish is an open free tool which allows you to enumerate websites, and it's scanning and searching for particular links that may be exposed through that. So it's essentially crawling the site, and it's learning about new links that may be publicly available. Once the tool is completed, it creates an index.html file, which our attacker here is going to open up in a web browser to have a look at the results of this particular scan. And we can see here that there are a number of URLs that are contained here. So there's this /struts2, which leads us to believe there may be a vulnerability on the server that we've discovered. Let's look at our network diagram here, and you can see where we are over on the top right-hand corner. We scanned the internet and we found this vulnerable IP address, and we're now going to dig in further and see if we can exploit it. What our attacker now does is goes into the Metasploit console. Metasploit is a framework that makes the task of hacking and exploiting various different systems much easier than normal. The framework contains known exploits, and you're able to index and search for various known exploits. In this case, we're looking for a struts2 exploit, and there was a well-known one at the beginning of 2017, and that's what we're showcasing here. Our attacker has to set some options as part of the commands being run here in the Metasploit console. So we're setting up the target IP. We're setting up the target URI or the /struts2-blank URL that you see there. And we're setting up a payload as well. And the payload is going to hopefully, if the exploit is successful, give us an insight into the machine and see where we get to from there. Now the attacker just simply types exploit, and this has actually been a success. So we've been able to compromise one of the publicly facing web servers on that external part of our network. The attacker now can run some commands against this server, and you can see here on a network diagram where we are, where the number 2 is, and essentially we've now exploited a vulnerable publicly facing server that's sitting on that right hand side, that public side of our network. So the attacker will run some commands just to kind of get a feel for this system that they've compromised, doing a sysinfo to determine that it's an Ubuntu box, a Linux server. We can look at the ARP cache, which gives us some idea of recent connections that the server may have had with other servers or other systems. We can determine what the user account is, the present working directory, which is Tomcat 8. So clearly we've compromised the box to the point where we are running as the Tomcat 8 user. And the attacker can have a look through some of the directories and sees this logs directory looks kind of interesting. So the attacker decides to have a look at some of these log files and see if the contents of these log files contain anything interesting. By outputting one of the private log files on this server, you can see that there are a number of entries in one of these. But it's a lot of stuff, and attackers will use tools to simply index and sort through that content, and in this case to filter down to only unique IP addresses that appear in this log file. Once the attacker does that in this case, we can see there's an interesting address which is 10.1.1.158. Now this is interesting because this is an internal IP address, and we can see that if we look at the configuration on this particular server that we've compromised, its address is 10.2.1.9. And this means there's potentially another network here inside this environment that perhaps we could have a look at getting to. In this situation, we set up a route on our compromised box, and we want to see if we can get to this other subnet that appears in this production environment. So these commands are just setting up a route to get to the 10.1.1 network. Now our attacker will run a port scan, a little bit similar to the end saw originally, where we want to look at anything that's going to be responding from a 10.1.1 address. So in this case, we're going to scan the /24 range, which is from 10.1.1.1 to 10.1.1.254, and see if there are any machines that are responding on any of those addresses. And we're only scanning for ports 2280, 443 and 8080 in this situation. We're doing a scan now of all 256 hosts, and we're already getting some results come back. We can see there's a 10.1.1.68 which is responding on port 22 and also on port 8080, as well as a .103, and we wait for the scan to complete. Now let's go back to our network diagram and see where we are. Well, we've discovered this other subnet, this 10.1.1, and what we're actually doing at this point is traversing across the VPC peering arrangement that sits at the center of our network diagram. Now we've discovered this 10.1.1.68 address, and what the attacker will now do is have a look at what this actually is. We simply do that by fetching a web page that is at port 8080 on that address, and we can see some HTML being returned here indicating that this is another Apache Tomcat server. Now, interestingly, there's a link here that suggests this is not only just a Tomcat server, but also has Jenkins running on it. Now, Metasploit has a number of built-in exploits that it ships with that are able to compromise Jenkins hosts. In fact, Jenkins servers as a continuous integration platform are almost deliberately vulnerable because of the way that they work. And there is a feature called Groovy Script, which is actually designed to help the build process in many development pipelines. What it means is your Jenkins server really does need to be isolated in an environment with very limited access. Otherwise, it's very easy to make use of that server, very easy to compromise it. In this case, we're also demonstrating quite an old version of Jenkins, and admittedly some of the newer versions of Jenkins are getting much better from a security standpoint than they have been previously. In this case, we want to use a particular module within Metasploit, and our attacker will load that up shortly to see what else we can do here. Searching for the particular module, we find the one which is just a Jenkins enumeration. This one's actually a script console. So let's have a look if the script console will respond and if we can do anything here. So again, these payloads need some options set, and that's what our attacker is doing right now. Okay, we're setting up a payload so that when this script gets executed on the Jenkins server, we can actually get a reverse shell and connect into the compromised server and then start to execute some commands remotely if it's successful. And our attacker types exploit and away it goes. And success, we're actually typing in some commands now that are being executed on that Jenkins server, such as ID, who am I, and you can see that again we're running as the Tomcat 8 user. So let's look at our network diagram, and you can see we're over near the number 4 now. We've successfully gained entry on the public side. We've traversed through a compromised host on that public side, and then we've been able to pivot through the VPC peering arrangement onto the Jenkins server, which we now have a shell on, and we can now execute some commands on that Jenkins server. Now, one of the interesting things about this Jenkins server is that it's hosted in Amazon. And what this means is that EC2 instances have what's called an IAM role that is typically assigned to them. And the method that Amazon uses for EC2 instances to discover the role that they've been assigned is simply through querying a specially crafted URL that means something inside the Amazon network. In this case, we're looking for the security credentials or the name of the assigned IAM role. And we can see here we get this S3 underscore get underscore role name, and this is the name of the role. Now, in our lab and our demonstration, what we're showing here is essentially that this particular role in IAM may not have been configured correctly. Now, what we can do is enumerate, again, through this same service that Amazon provide to EC2 instances, some of the ephemeral or the temporary credentials that are assigned to this EC2 instance. In this case, we see the access key ID and the secret access key along with a session token as well. And these 3 parameters can be used to imitate AWS commands as if they're coming from the EC2 instance. We're setting up some options here for another attack to see if we can leverage these particular credentials that are part of this EC2 instance. And what the attacker wants to do now is see if they can actually take over the AWS account by creating another user. You can see here the two successful sessions that we've got. One session through to the first compromised host, the 10.2.1.9, and then we're pivoting from there through to the Jenkins server to the 10.1.1.68. So we're now using a module in Metasploit, which is the AWS Create IAM user. We need to set up some parameters here, such as a fictitious group name that we're going to create, which is called hacker group. This is going to have a very widespread policy, which we'll demonstrate at the end. And we also set up our password, in this case test123, and the username hacker. And now we're going to fire this off. But first we need to enter some of the credentials as well, such as the session token. We've already entered the access key and the secret access key ID. We run that and it's now making these calls through that server, pretending to be the EC2 instance, and it's actually failed in this case, and it looks like the password does not conform to the account password policy. This is a good example to show you that hackers don't always get it right the first time. In this case, the hacker does need to use a stronger password that's going to conform to the policy. So the hacker will now set the password to do that and try again. So we're using test123 at hacker now as the password, which should conform to the password policy, we hope. And we wait for the status, and yes, that has been successful. And we can see here we get the username, the group name, the password, and the account ID. And it's simply a case now of seeing whether these credentials are going to work in the Amazon console. Before we do that, let's have a look at our network diagram again. And we see here we've now compromised potentially the identity and access management part of this AWS account. And this is a multi-step attack. As you can see, we've come through the public side, through the VPC peering arrangement, onto the Jenkins server, and then through a poorly configured IAM role in the AWS environment, we potentially now have credentials to log in to the AWS account. And our hacker is doing exactly that now. And sure enough, the credentials work, and the attacker is able to enter into the AWS console as if they were the customer themselves. So you can see the power of this type of attack. And these are things that really only happen in cloud-based environments. We need to take extra precautions to eliminate this type of thing from happening. And of course, identity and access management in a lot of cloud systems is quite complicated and needs a little bit of effort to get right. Having a look here at the policy that this particular user has been configured with, and it's effectively a star.star representation, which means this particular hacker account can do virtually anything inside this AWS account. We have demonstrated how what would be a very commonly deployed environment, most likely operating in many DevOps shops, can be compromised by hackers operating over the internet. The result is a total compromise of the AWS account, resulting in the attacker gaining complete control of the account, to the point that the genuine owner could actually be locked out of their own environment. In the sense of security DevSecOps labs and tutorials, we're learning about active and passive security automation across the entire stack, which means every layer in the environment, from the application that is developed and published to the internet, to the application delivery framework, the operating systems that it runs on, the networking environment that delivers it, and the development tools that build and deploy it, and the cloud platform that it is hosted on. This particular attack that you've just seen could have been prevented from occurring, or at the very least from progressing as far as a total compromise of the cloud account. For every successful attack point demonstrated across the network diagram, we have a preventative measure which can be automated and also self-healing. This means that without any human intervention, you can configure your DevOps environment to be secure and to automatically self-heal when changes are attempted to be made to your environment. We call this tamper-proofing your cloud deployment. We encourage you to join our DevSecOps lab and learn more about automated security across the full stack to put you in a position to protect your DevOps investment. Thank you from the team at Sense of Security, and contact us on info@senseofsecurity.com.au at any time.